Welcome to the course on molecules in motion. This course is intended for students who are doing their undergraduate, whether they are in science stream or they are in engineering. What we will be looking into in this particular course is the molecular motion of the part in the system. When we talk about a molecular motion in a particular medium, we talk about the three phases: the gases, the liquids and the solids. And here we will focus mainly on the gaseous phase and the liquid phase, and the properties of these atoms or molecules. Actually, the molecular behavior in a particular medium, various fluid medium, is very important, and it has a lot of application where you can use them. So, it is imperative that you learn about some of the methods or some of the approaches to understand the motion of molecules or atoms in a particular media system, like a gas, or we can say that any fluid system. In this particular course, what will be covered, I am going to briefly go into those topics which is going to be taken up in this particular course. What we will begin with, we will talk about the molecular motion in the gas phase, and we will begin our discussion with the kinetic theory of gases, the simplest of the model, where we have the Brownian motion or random motion of the molecules in the system. And from this, what do? We go on to using this concept of theory of kinetic theory of gases, we go on to establish the concept of pressure of a gas, the rate of migration of molecules and energy through the gas medium. And what we use the Maxwell's distribution to understand the speed at which they move or the rate of their migration. And then we eventually discuss upon the molecular speeds, how the collision frequency, what is the collision frequency, what do you mean by collision frequency, how frequently the atoms or molecules are colliding with each other. We go on to understand what is the mean free path and how do we calculate that. What is the mean free path? It is the distance travelled between two consecutive collisions. After that, what we go on to do in this syllabus, in the course, is we talk about the collisions of these gas molecules with the walls and surfaces. The rate at which they strike a particular area is what we are going to focus on. Then we have the rate of effusion, like how, at what rate does the particle or a molecule come out of a particular hole. And in that category, we will discuss the Graham's law of rate of effusion, in which we find out that the rate of effusion is inversely proportional to the square of the molecular mass. After that, this is obviously covered under the molecular motions in the gas phase. What we do next is we talk about the transport properties of these particles in the gas phase. Transport property is a very important concept to be understood, because it has lot of application. What does it mean? It is the ability of a substance to transfer matter, mass and some other properties like momentum from one place to another. This is what we are going to be talking about when we are talking about the transport properties. And why is it important? To design a particular reactor or a particular flow system in a manufacturing process, like in an oil industry or in a chemical industry or even in the pharmaceuticals or biotechnological industries, you need, for designing them, you need to know at which rate they can be transported. So, it is important that we know about the transport properties of a particular type of molecule and a particular type of medium. It characterizes the properties of flow. It depends on rather the rate at which is going to be flowing. or the response of a flow system to temperature, the composition and other gradients. So, we will look into that, and what are the things we are going to discuss under this. There are 4 important transport properties, there may be others, we will be discussing only 4 properties in this particular section, which is only going to include the gas phase. What are we going to be discussing? We are going to be discussing the 4 transport properties: diffusion, thermal conduction, electrical conduction and viscosity. Diffusion is what? You have a movement or transport or migration of matter due to the driving force is the gradient, concentration gradient. Similarly, we have thermal conduction, we have the migration or transport of energy due to a temperature gradient. Similarly, when you have electrical conduction, you have migration of an electric charge along an electrical potential gradient. Similarly, we can talk about another transport property, the viscosity, the migration of linear momentum down a velocity gradient. So, these are the 4 properties which we are going to discuss in detail and derive their concept. After that, we are going to move on to a different phase, that means a liquid phase. So, what we are looking into previously was the gas phase, now we are looking into the molecular motion in the liquid phase. Here we are going to be looking into a particular type of ions in a medium which is a liquid and in presence of an electrical field. The purpose of this is whether this ions with whatever we derive or whatever concept we establish, can it be further extended to molecules which are not charged. That is what we are going to do. We will first derive the concept of movement of ions in a liquid phase, that is liquid, in presence of an electric field, and whatever concept we have developed, we will try to extrapolate that to another to the system where the particles are not charged, they are neutral, they are molecules or atoms which are neutral. So, if before that, when we are discussing about the ions in the liquid medium or the liquid phase, what we will be looking into is the conductivities of the electrolyte. Electrolyte is a system where you have ions in solution. So, what we will be discussing under this is the strong electrolyte, weak electrolyte, and following that is the Colorocious law of independent migration of ions. We will continue this concept of molecular motion in liquids to understand the mobilities of the ion in the system. What is the drift speed, what is mobility, what is conductivity, what are transport numbers and how do we find them out, because these are important parameters for characterizing a system which is having ions. So, we will look into these, and following that we will try to understand what is the relation between conductivity and ion-ion interaction. For ion-ion interactions, there are 2 concepts which are very important to establish the theory of conductivities of an electrolyte. One is the relaxation effect, following it that we are going to discuss the electrophoretic effect, and using these 2 interactions of ions, we are going to establish or talk about the Debye-Huckel-Onsager theory. That is for a system where you have ions under an electric field in a solution or liquid medium. After this, what we will do is whatever we have established in the ionic medium, in ions, using the ions in a liquid medium, we are going to extend that to a neutral molecule and see whether the behavior or the concepts we have developed there can be extended to a particle which is not charged and is not under the influence of an electric field. In this, what we are going to do, the topics which we are going to be particularly looking into is the thermodynamic view of diffusion. What we will include here is the thermodynamic force of concentration gradient, which is going to be the driving force for any diffusion process. Then we will discuss the first law of diffusion, establish the relation between these 2 parameters which we have established through Einstein relationship, Nernst-Einstein equation. Stokes-Einstein equation. This will more or less summarize what will be the content of the syllabus in the subject we are going to be discussing is the molecules in motion. What I would like to emphasize, to do this course we do not really require any prerequisite as such, but you need to know little bit about the real gases and the ideal gases. You need to know about ions, you need to know about the atoms and molecules. I think these are very fundamental and all of you have done in your class 2 syllabus, plus 2 syllabus. Apart from that, it would be required that you know some bit of partial differential or not partial differential exactly, you know a calculus. If you know calculus, you know differential, differentiation and integration, that should be sufficient for taking up this course. In this course, your question answers will be addressed by 2 of the Department of Chemistry senior research scholars. They are going to be helping you in your in the evaluation as well as answering your questions and queries whichever you put up, and these are senior research scholars of the Department of Chemistry.
I am Dipanjan Samanta from the Department of Chemistry, IIT Kharagpur.
Hello, I am Madhusudan Kumar Mathu, doing my PhD in Department of Chemistry.
Thank you.